Can you already imagine the Hyperloop tubes being part of the landscape? In order to realize a Hyperloop system, a lot of infrastructure will be needed. In this lecture, I will tell you everything you need to know about the infrastructure that is needed for a Hyperloop system. Not only the tubes will be described, but also the track, tunnels, overseas connections, and the implications for spatial planning. Furthermore, stations, solar panels, and the total cost will be presented. It all starts with the main components of the Hyperloop system, the tube and the track. The diameter of the tube is dependent on the size of the pods, which need to be sufficiently large to be able to transport many passengers. It is most likely that the tubes will be made out of steel due to its high strength-to-weight ratio. But multiple companies are also investigating the use of concrete or composites. For the track, it is important to have a conducting sheet. Otherwise, the magnetic levitation will not work. Furthermore, the linear motor for the propulsion of the vehicle will be integrated in the track. Another important aspect of the Hyperloop is its near vacuum condition. Therefore, many vacuum pumps are needed to keep the desired pressure of 10 Pascal, which is only 0.01% of the atmospheric pressure we are currently breathing in. This number is an optimization between the energy used to maintain the near vacuum and the energy savings for all Hyperloop pods traveling in the near vacuum tube. The thickness of the tube also needs to be sufficiently thick to withstand the pressure difference between both sides of the tube. As the Hyperloop will reach speeds of around 1,000 km per hour, it is important that the track is extremely straight. Otherwise, it will lead to high discomfort for the passengers. Imagine the implication this will have for spatial planning. Think of any nearby large city in your region. Do you think it is possible to construct a Hyperloop tube above ground? Although a bidirectional Hyperloop will only take up the same surface as two highway lanes, it is almost impossible to incorporate it above ground in highly populated areas. Therefore, the Hyperloop needs to go underground at certain locations, and tunnels are needed. Other advantages of tunnels are the reduced landscape pollution, the reduced noise, and the increased safety in earthquake-prone areas. However, large drawbacks are the increased costs and low construction speed. Current tunnel boring machines can only tunnel with a speed of 15 meters per day. So, by going underground, land use problems can be solved. However, when creating a Hyperloop network, another problem might arise: overseas connections. Tunneling under the seabed is possible, but as mentioned before, this is very slow and costly. Another option might be to lay down Hyperloop tubes with pipe-lay methods that are currently used for gas and oil pipes. The Pioneering Spirit, for example, one of the largest ships in the world, is the leading vessel in the pipe-laying industry. It can lay pipelines with a diameter up to 1.7 meter. However, this is still significantly smaller than the 3.5 meter diameter that is needed for a Hyperloop tube. When reaching the destination, a Hyperloop pod will arrive at the station. But before the passengers can disembark, the pods need to transfer from the near vacuum environment to the atmospheric pressure. This can be done by using airlocks, which are large vacuum chambers, where the pressure around the pod can be reduced or increased. This is comparable in use to the transfer of astronauts to and from space stations. The location of a station is also really important. It would be ideal to locate it underground in city centers, as this diminishes access and egress transport. However, that is not always possible due to restricted space or large costs. Furthermore, to increase the potential of a Hyperloop system, it is important that Hyperloop stations have a good connection with other transportation systems. In that way, transfers can be made easily, enlarging the ease of use for the passengers. All the infrastructure needed for the Hyperloop will cost a lot of money. It is estimated that above-ground infrastructure will cost almost 40 million euro per kilometer, whereas underground infrastructure will cost 60 million euro per kilometer. All infrastructure aspects mentioned in this video are included in this estimation. The largest part of these costs are caused by tunneling, the propulsion system, and the amount of steel used for the tubes. To be even more energy efficient, solar panels can be placed on top of above-ground infrastructure. After watching this video, I hope you realize that building a Hyperloop system is not so easy and will bring a lot of implications regarding the infrastructure. However, that should not stop us from building a Hyperloop, as other transportation systems cope with the same issues. Are you curious to know more about the infrastructure? Have a look at the additional reading material that is provided. Thanks for listening and see you in the next video.